Tonight on the bench, we've got a pair of Dynaco Mark IIIs. These are a friend of mine's. He bought them a few years ago from a local so-called Dynaco expert who rebuilds a pair of these roughly every year and puts them up for sale. And I guess they worked for a few months, and then the one on the left, the filter capacitor exploded and shot sparks out everywhere. So he took it to another one of the local so-called experts, someone else who replaced the filter cap. And ever since then, it's never worked right. It's apparently got really bad distortion. He also mentioned that the bias drifts up on both of these. So in this video, we're going to see what's going on and see if we can restore this one back to normal operation. And at the end of the video, we'll test out both of them and see how they perform on some of the test equipment I have here. All right, let's take a look at these. I took the cover and the bottom plate off. So we're looking at the one that has the issue here. We can see that the person that restored these replaced the printed circuit boards with some aftermarket replacements. It's the original clone, so it uses the 6AN8. I see he's got some, I'm not sure who makes these capacitors, the ones that are labeled CAT224-6C. I can't find anything online. Probably give them the benefit of the doubt. I'm sure they're 0.22 instead of the original 0.25 microfarad, but the voltage rating is unknown. I'm hoping the 6 means 600. I see a Russian K40Y paper and oil capacitor there. I see some polystyrene capacitors, which I'm not sure how I feel about polystyrene being that close to these tubes, which run really hot. I probably wouldn't have put them in there. I also see some cheap, no-name Amazon metal oxide resistors. I'm not a fan of them. The metal oxide resistors have bad temperature coefficient. Not that it really matters too much. They're still a lot better than the carbon comps that were in here, but considering a much higher quality metal film resistor is something like 12 cents a piece from DigiKey or Mauser, I don't see any reason to use these. We've got some Nestone branded 6550s in here right now. He also provided me a set of Lin Lai KT88s. These are also Chinese tubes, but they're supposedly premium, somewhat expensive Chinese tubes. So those are the ones that he wants in this when he gets it back. So at the end of the video, after we repair this, we'll put these Lin Lai KT88s in there, and we'll set the bias on it using my Levier distortion analyzer so we can dial it in a little bit better than we could just by using the bias set procedure that's built into these. And then we see a JJ GC34 rectifier tube, and this is the CE manufacturing can cap, so this is the replaced cap, and it's the upgraded 80, 40, 30, 20 microfarad. The thing that I don't like about this is that it's a 525 volt capacitor, and these things are known to exceed 525 volts, especially when you first turn them on. And the other thing that I don't like is that it's rated 55 degrees Celsius. I prefer using 105 degrees Celsius capacitors, especially when it's right next to tubes and there's a cover on it. But that's just what you got to deal with when you're using this CE brand. They have pretty low temp ratings. And the other thing is there's no surge rating on here. And I couldn't find anything on their website about a surge rating. So on the topic of capacitor temperature rating, here's an example of something I found in a fully restored Scott 299 that I had to repair for someone. This is a 3-section CE. It's a 40, 20, 20 microfarad, and all sections are rated at 500 volts. It's rated at 55 degrees Celsius. The picture I'm showing on the screen is the actual picture of it. And there's nothing wrong with it, except if you look at the thermal camera, 55 Celsius is 130 degrees Fahrenheit, and it's already hitting 125. It hadn't even been on that long at that point, and there was no wood case or metal cover on it like you can run these with, and it wasn't installed inside of a cabinet or anything. So I was completely uncomfortable with that temperature rating, and I replaced it with some discrete capacitors. Let's take a look at the outside of the good amp before we flip them over. So this one's similar. It actually has a different brand printed circuit board in it. It is a replacement. I noticed this one is not through-hole plated like the other one is. But other than that, it's very similar. And these are General Electric 6AN8s. I tested all the tubes already. One of the 6AN8s is weak, so we might address that as well. Power tubes are basically brand new, and so are the rectifiers. Then the difference here is that this one, it has a Authentic Cap branded capacitor. If I'm working on an amp like this myself and the person wants to maintain the original can cap, I prefer using the Authentic Caps over the CE. They have a higher temperature rating. It's not listed on here, but according to their website, it's 70 degrees Celsius, so it's a bit better. It's still not 85 or 105, but it's pretty much the best you can do unless you get maybe like a Hayseed Hamfest, which is actually just discrete capacitors in a can. And the other thing is that this is a 550 volt continuous 600 volt surge rated capacitor, so this is a much better fit to this amplifier. So what we're doing is I'm going to get the broken one working in the video with the CE capacitor, and then he ordered another one of these, so they're both going to match. They're both going to have the Authentic Cap 30-20-20-20. So it was either that or buy two Authentic Cap 80-40-30-20s, and they're about $75 a piece, so going the cheaper route for now. Let's take a look at the bottom of these. Okay, for this portion of the video, I'm using the Vuzix M400 smart glasses. I thought that they would help me really get down in here and show this to you guys with a bit more detail. They seem to do a really good job at focusing when you're up close compared to my regular camera. So here's the bottom of the bad amplifier. The first thing you notice is just the really sloppy workmanship overall. Take a look at that PCB. There's flux residue everywhere. I see a bunch of cold solder joints. None of the leads were trimmed, which there's no excuse for that. Why would you do that? Coming down here, there's no proper strain relief on the power cord. This cutout here actually has the flat sides on it, which mean it's meant to be used with a Hayco bushing. The other one does have the Hayco bushing. I also noticed that this one has a polarized power cord. The other one does not. I would prefer that they both have a polarized power cord. We noticed that it has the wrong fuse in it right away. It's supposed to be a slow blow fuse, but it is a 3 amp fast blow, which I'm okay with for now. It gives us a bit more safety, but once these are operating normally, we want the original slow blow in there, because if he's really pushing these hard, the fast blow might blow unexpectedly. And you can see just overall sloppy workmanship. Like if you look at this terminal strip here for the bias supply, he didn't even wrap the leads around the lugs. They're just kind of stuck through and soldered to each other. That's not ideal. We still have the original 1000 ohm resistor there, which you generally need to increase the value of when you replace the selenium rectifier with silicon. I don't like how the capacitor, I'm okay with using radial capacitors, but I like to put like tubing over the leads so they're not just flapping in the breeze there. We're actually going to replace those with the correct axial capacitors. They're only just under $3 each, so why not do it right? Again, more of the sloppy workmanship here on this capacitor. The leads are just kind of stuck through and there's no mechanical connection at all. And the theme just continues up here with all of the lugs on the tube sockets. There's a couple mods we'll talk about doing. The first one that he wants done is the yellow sheet mod on the rectifier tube, where you add a couple of 1N4007 diodes. I believe that's to prevent arcing in the tube under certain conditions. And there's another mod you can do. It's called the screen stability resistor. You install it on the tube socket in series with the lead from the output transformer screen tap. And again, another capacitor that we'll replace here with the proper axial. Again, I don't like this lead just kind of flapping in the breeze up there. It doesn't cost much to do it the right way. So we'll go ahead and get that cleaned up, clean up all the flux, clean up the leads. Let's take a look at the other one. Again, the same shoddy workmanship, especially around the terminal strips. No excuse for it. This one does have the Hayco bushing. It also has the wrong fuse, and it's pretty similar. We're actually buying another one of these vintage Electron boards, and I'm going to swap it into this unit so that they match, because he might sell these and it just looks a lot better when they're both identical. And there's also this resistor here installed on this unit, which is not on this one. I have to double check and see what that does. I think it's for the preamp power supply based on how it's going to the preamp power connector. We may also replace the input jack here. The phenolic is cracked on that. He gave me another one to replace it with. He told me don't worry about it unless this one's actually got an issue with the connection. It's actually pretty solid, but it is broken, so we'll consider doing that as well. We will have to drill the rivets out and use regular pop rivets or screws. And another small complaint about the workmanship here is with how the filter capacitor is mounted. And this is a twist lock capacitor, and you can see that the tabs were just folded over and pressed down. It works, but I feel like actually twisting them gives you a better mechanical connection to the chassis and lowers the resistance between the can and the chassis. They actually make a tool for it. I have one. It's made by GC Electronics, and the part number is 9446. And it's great for installing and removing them. So here's an example. It just fits over the tab and you can turn it. Alright, so let's get back to the actual problem here. Now unfortunately I'm not going to be powering the amp on and demonstrating the distortion that it has, because I actually know what the problem is now after studying this. So let's take a look at the good one, and I'll explain how the rectifier tube is connected to the can capacitor. And as a reminder, this is the original value can capacitor, so 30, 20, 20, 20. So if we take a look at the schematic, pin 8 coming off of the rectifier tube goes into the first capacitor, which is the 30, which is the half moon. And then it goes through the choke, and then that's connected on the other side of that to the 20, which is the square. So if we look here, so here's pin 8 on the rectifier. The black wire goes to the choke, and then the red wire goes over to the half moon. So that's good. And then we see the other black wire from the choke goes into the square, and then there's a 6.8K resistor, which is there. Oh, out of frame a little bit. Which is there, and that connects to eyelet 5. So if we take a look, so there's the 6.8K. It's going from the square to the circle, and then if I move the camera, the red wire is going to eyelet 5 there. So that's our high voltage. And that's good. And then this black wire here, which is connected to the triangle, goes over to eyelet 6. And we see that one here. So that's how it's supposed to be wired. Let's look at the other one, the broken amp. And the reason I went straight to looking at this was because, well, we still don't know why the original authentic cap blew up in this one. I never saw it, don't know anything about it, but I do know that somebody replaced it. And the thing is, with the upgraded capacitor, the 80, 40, 30, 20, you need to change the connections. There's 2 wires that have to be swapped on there, because what you can't do is you can't have the first capacitor after the rectifier higher than 60 microfarads according to the data sheet. So it would be 80. So what they do is they swap the square and the half moon connections. So now pin 8 from our rectifier is connected to the square here on the bottom instead of the half moon. And the square on this, let me just double check, is 40 microfarads. So what the problem here is that this person installed this resistor incorrectly. This resistor is currently going from the half moon to the triangle, and the triangle goes over to pin 6 on the printed circuit board, which it is not supposed to do. So this resistor is supposed to be installed from this guy here to this pin here. And that's the unmarked one on this CE capacitor. So we're going to fix that, and then we'll power this thing on and see what happens. Alright, so I've got it plugged in at the bench. I've got it connected to the dim bulb and variac combo unit there. I've got the multimeter hooked up to this point here so I can watch the 480 volts rise. And that's about it. So I'm going to go ahead and turn it on. I've already got the power switch on the unit on. I've got it connected to an 8 ohm dummy load as well. And I've got 2 bulbs in it right now, so it's about 100 watts, so it's going to start slowly. Then I'll switch the third one in. That's another 200 watt bulb, so I'll bring it up to 300 total. I'm going to do that instead of using the variac. I'll leave the variac at 120 volts. There we go. So we've got 60 volts, 70 volts, 80 volts. Again, it's limited by 100 watts with the light bulbs right now. And I expect that number sort of about 90 volts. And then once the rectifier warms up, that number is going to drop. It's pulling about 30 watts right now. We're at 350 volts. And now it's dropping. You see this is dropping here. So what I'm going to do is I'm going to switch the final bulb in so that'll be equivalent to 300 watts of dim bulb limiting. So that jumped back up. So we're at 460 volts. And it's continuing to warm up. That'll probably jump around a bit here for a minute. Let's see, so we're at 100 volts right now. Again, it's limited by the bulbs, and we are pulling in around 80 watts, 85 watts. Voltage is at 401. If I cut the dim bulb limiter altogether, that should go up. But what I'm going to do is, I've got this plugged into dummy load. I've got it plugged into the distortion analyzer. So I'm going to give it a signal. Let's see what we get. It's a 100 millivolt signal. So there's our sine wave. The fuzzy stuff in the background is the residual distortion. And the line on the bottom is just because that's for the second channel, which we're not using right now. With 100 millivolts of signal going into it, it's making 0.21 watts at 0.016% distortion. I think what I'm going to do now is I'm going to take it off the dim bulb limiter. Let's take a look here. Get back down here. So I switch this into direct. Go. So now we're at around 120 volts, 485 volts DC, which makes sense that it's a bit higher than the original spec of 480 since the line voltage here is higher. And then I think what we'll do now is we'll check the bias to see if it's around that 1.56 volts that they call for. Okay, the bias is a bit high, 1.74. We're going to lower that to around 1.56. All right, that's good enough for now. And now what I'm going to do is I'm going to go back to the distortion analyzer. And let's see what this thing does. I actually need to look up the spec on this. I'm not sure how much power it's supposed to make off the top of my head. They say 60 watts, but that was before they had a standard on measuring power, so I think that's a bit optimistic. All right, so let's give this 200 millivolts. 0.84 watts, 0.01% distortion. I'm going to go up to 400. Sometimes the relay's on the analyzer. So we're making 3.4 watts at 0.01. Let's go to 600. 7.6 at 0.02. Let's go to 800. 13.5 at 0.06. Try 1 volt. 21 watts at 0.1. Let's try 1.1. 25 watts at 0.15. 1.2. 30 watts, 0.18. 1.3, 35 watts at 0.18, that's good, 1.4, 40 watts at 0.2, I'm going to stop there for now. I'd say the problem's fixed because it was only making like 5 watts before when we were hooking it up, and obviously we found that it was clearly wired wrong. Alright, I'm going to end the video here for now. We got the original bad amp working, and in the next video we're going to talk about all the improvements I made to that amp after fixing it. This here is in the future, and I've already rebuilt the board, so we'll talk about everything that I did there and why I chose to do it. We'll talk about adding a CL80 inrush current limiter, and I ran some tests with my HP AC power analyzer. The 6813A has an inrush current measurement mode, which is pretty neat, showing the inrush waveform, so we'll compare before and after the CL80. The other thing that we'll do is we'll do some more tests. We'll do some frequency response tests with HP 3562. We'll do some more THD distortion tests with the audio analyzer here. Maybe we'll compare these Nest Tone tubes to the Lin-Li tubes. That might actually be a third or fourth video at this point. And the other thing that I'd like to do is, so this is the amp that I was talking about in this video. It's basically fully rebuilt at this point. The other one, the one that didn't have any problems, I left it original, and we can compare them to see if there's any difference in those tests I just mentioned with the different capacitors and things like that. And the other thing I'll mention is, I didn't know what these caps were at the beginning. Apparently, somebody told me on the Dynaco Den Facebook page, they're the company Convergent Audio Technologies, and they suggested that they might have been a pull out of a Convergent Audio amp. And those amps are expensive boutique amps, right? So no one's getting pulls out of them, but apparently they're actually local here in town. I didn't know that, so I think the guy that rebuilt this must have been buddies with them and got some of their caps to use in these builds. The other thing that if people are interested in, I can run some tests on the caps. I have the HP 4192 impedance analyzer here, and I actually played around a little bit. I ran an impedance sweep against these Illinois .22s versus these Cat .22s, and I also ran a sweep on the Russian K42Y 0.1. Nothing too interesting there, but if that's something that people want to see, let me know, and maybe I'll make a video on it. So any other suggestions or tests you want to see with these Dynaco Mark IIIs, let me know, and I'll see if we can get a video done on them. Thanks for watching.